Okay. All right, let's do this. I'm going to share Google Chrome. Okay, so hopefully you should be able to see my screen. Okay, so what are we doing today? Let's go over what the goals and agenda are for today. Goal, hopefully by the end of this class, you will know how to take a graph and find the slope of the best fit line. So that's what I want you to be able to do, is find the slope of a graph. If you already know how to do that, great. Today's going to be super easy. If you're not sure you remember how to do that, don't worry. I'm going to go over it step by step. So agenda for today. The first thing we're going to do is discuss graphing practice 1. We're going to do that as a class. Second thing we're going to do is the slope notes. So we're going to take some notes on slope. And the third thing we're going to do is go over some, you're going to have some time to do slope practice. Okay, so hopefully this goes nice and quick. So open graphing practice 1 in Notability. That's what you should be doing right now. You're going to want to do it split screen with WebEx. And then what I'm going to do is show you an example of what a student did for graphing practice 1. The first thing that you are going to do is list all the things that student did right. You're going to do it in the chat. And I'll give you some examples of some things that you can talk about in just a second here. After we've listed absolutely everything that they've done correctly, then we're going to list the things that that student did wrong. And then, after we do all that, you're going to make some corrections to your practice. So hopefully everyone gets what they're doing. If you have any questions, now would be the time to ask. Jade, I'm just going to mute you, okay? If you need to say something, feel free to unmute and ask. Okay, what should a good graph have, though? So this is what I want you to be looking at when you're looking at this student's work. Does their graph have a title? Do the x-axis and y-axis have a title? Do those titles include units? Does the x-axis have the correct scale? Does the y-axis have the correct scale? And how you'll be able to tell is when they graphed it, did they pretty much use the whole graph? Data, did they plot all the data correctly? And lastly, the best fit line. Does the best fit line go through the middle of the data? So these are all things that you should look at to see that they did correctly or incorrectly. Okay, so let's pick a student. And if you're the student that I'm picking on, I apologize. I'm not trying to like call you out or anything. I'm just picking an example at random. Okay, so graphing practice 1, that was in day 2 if you haven't started it yet, so you can get going on it. Graphing practice 1. And then let's just pick someone at random. Well, let me ask you this first. In the chat, does anyone want to volunteer to be the person that gets theirs critiqued?
Sure, I can. If you guys want me to.
Who said that?
Me, Julian.
Julian. Okay, I'm gonna share yours.
Well.
Did you submit it already?
Yeah, I submitted on time.
All right, dope. Let's take a look.
Julian, if you don't want to, I will volunteer as well.
All right.
Okay, well, we're going to do Julian's first, and then if we have time, who said that?
Samuel Pierce.
Samuel, if we have time, we'll do yours as well, okay?
All right.
The nice advantage about getting yours critiqued is you're going to be able to find out exactly what looks good or what doesn't look good on your graph. And so it's a great way to sort of get feedback on your graph. Okay, let's zoom out of this just a little bit so that we can see the full graph and the data table. That looks better. Okay, so go ahead, type out in the chat, what do you think looks good on Julian's graph? That's what we're starting with, is what looks good. And so just real quick here, let's just review what types of things we're talking about. Does his title look good? Does his x-axis look good? Does his y-axis title look good? Scales. Did he plot the data correctly? And is the best fit line a straight line that goes through the middle of the data? So all things to think about. Let's take a look. And let's see here. So Jay says the best fit line. I agree. That's a good best fit line. It's straight and it goes through the middle of the data. Meta says his x-axis. What on the x-axis? The scale, the title. What looks good, Meta? Anda says that the graph title is good. Anda, I don't think I marked you present, so let me go back and do that. Okay, you are present, Anda. So if you get a message from the district, it's because I didn't get you right away, but you should be present now. Okay, so the x-axis looks good. The graph title looks good. Yes, title is good, not food. I agree, Mohammed. Axis scale. Which axis scale looks good, Rodolfo? X. Yeah, I agree. I think the x-axis scale looks really good. Goes by 0, goes up to 40. And we can tell he did a good job with the axis scale because look, when he graphed it, he pretty much used the whole graph. The graph pretty much took up the whole piece of paper. So that's a good sign that you did a good job. Okay. Good. What could he improve upon? What could he do better?
He could have improved on the y-axis.
The y-axis, good. What about the y-axis could use improvement?
It's missing the number 25, and it doesn't go all the way. It's missing 15,
Yeah, that's
10,
another.
and 5. And it goes up by 4 rather than 5.
Oh, so the y-axis is actually mass. So
Never
that one
mind,
does
sorry.
go up to 20. But what could be better about the y-axis scale though, even though it does go up to 20?
It doesn't have a title.
It doesn't have a title. Good. So the y-axis needs a title. Excellent. And then how about with the scale? What could be better with the y-axis scale?
It's missing some numbers.
Yeah, and it's fine if you want to skip like from 16 to 20, that's fine, and 12 to 16, that's fine. But then if you're going to count by fours, count by fours. So I would include, put 8 down here, put like 4 right here. In general, this is really good. So excellent job, Julian. Okay, and then I have one other critique. The units for volume is centimeters cubed, not centimeters. So I know you can't do superscripts in Notability. So you could either draw a 3 on there, or if you just want to write the number 3 just as, not as a superscript, just as normal, that's fine. But I like that you included centimeters with your axis title down here. You just needed to include the 3. So that's good. Okay, so good job, Julian. Let's take a look at your first answer. And so before we do that, I just want to talk about what should an answer in science have. Well, your answer in science should have the correct number or value. It should include units, and you should show work. So those 3 things should be there all the time. Every single answer that you put down in my science class, I expect you to do those 3. I mean, assuming it's a numerical answer. If I'm asking you, to write a sentence, then write a sentence. Great answers are written as a sentence, though. So that's sort of like a next level step. If you want to write your answer as a sentence, and I'll maybe model how to do that for this one, we'll talk about what that would look like. Okay, so let's critique Julian's answer then. Julian says approximately 10 grams. So first, let's take a look at his number, the value. He said 10 grams. So if the mass what would the mass be if the volume is 12 centimeters? So we're going to take 12 and we're going to follow it up to here, like about here-ish, and then we'll follow it over. So yeah, according to your line, 10 would be right here. I think it's probably a little bit less than 10, but 10 is a really good estimate. So that's fine for a numerical answer. Approximately 10, that looks good. What else did you do good, Julian? You included units. It is 10 grams. If you had written mass in grams on the y-axis title, it would have been even better. So that would have been good. The one thing that's kind of tricky is I do want you to show work. Well, how the heck do you show work for this? This is kind of a weird one. Well, let me tell you what some of the honors students did for showing work on theirs. One thing that the honors student did that I critiqued today is they circled. So if we go if we go a volume of 12 and we follow it up to here, maybe what you should do is circle this part right here, and then I know where you were getting 10 from. That would be like over here. Another way you could do it is you could do it like I did in the lesson on Tuesday. So you could start at 12, you could draw a straight line up, and then you could draw a straight line over. Right? So that would be another way that you could show work. A third way, and this one's sort of next level, so if you're not ready for this, don't worry about it. But a third way you could do it is if you know how to find the equation of this line, you could use the equation of the line, and then you could calculate exactly what the mass would be. That's sort of next level. So if you're not there yet, anyone, don't worry about it. That's something that we're going to be talking about eventually here. But if you know how to do it, the advantage of doing it that way is that you're going to get exact answers. And it's not going to be an estimate. But in general, really good job, Julian. This is a very nice graph. Okay, let's do this then. Let's for the second graph, let's take a look at Sam's because Sam wanted to volunteer. So we'll go here. Sam, excellent. Go like that. Zoom out a little bit so that we can see it better. I'm sorry, did someone say something? Okay. Oh, yeah, I'm glad we're doing your Sam because you had a really unique way of showing work and I really liked it. Okay, so let's critique Sam's. What looks good about his graph? And remember, some things that you can talk about are title, axis titles. You can talk about data points. You can talk about the best fit line. You can talk about scale. All these things are important. Good. So, Kaylin, you like the
Fit line.
What's that?
The best fit line.
Oh, the best fit line. Good. Yeah, I like the best fit line as well. Yep, and Kaylin does as well. Kaylin, which title are you talking about? Are you talking about the graph title? Or well, yeah, okay, I guess we didn't see axis title. So remember for the graph title, the title's pretty good. It's missing one thing. Or there's one thing that's a little bit off about it, is what I should say. Anybody spot it?
It's supposed to be Y versus X.
It should be Y versus X. So remember that time is your X variable and distance is your Y variable. So really it should be distance versus time instead of time versus distance. But other than that, your title looks good. I like that you at least attempted to use the variables in the title, so that's good. Yeah, he was very clear with his answers and used full sentences. So yeah, this was a very good next level answer. And so we'll go over the answer in a minute here. Anda said that the y-axis scale was good. I totally agree with that. If you take a look at this one, 198 is our biggest distance. And so 200 is like perfect because 200 is just a little bit bigger than 198 and it's divisible by 20, which is important because there's 20 boxes here. So 200 divided by 20 is 10. So that's how he knew how to count by tens. Okay, so what needs improvement?
his X and Y scales don't have titles.
X and Y axes need titles. Yep. And so make sure to include units. So what should the title on the Y axis be?
Distance.
Yeah, distance. Good. And remember to include units. So distance and then put centimeters in parentheses. What should the title on the X axis be?
Time in seconds.
Yep, time in seconds. Good. Okay. Okay. What else? One last thing, and this one was maybe a tough one to catch. That's why I'm going to point it out. So if you look at this, the x-axis isn't quite spaced out correctly. And so I just want to show you why. I like what you did with it. Like you used the whole graph, and you, you know, you just made very good use of your space. But if you look, this 3 is 1, 2, 3, 4, 5 spots over from the 0. The 6 is 1, 2, 3, 4, 5 spots over from the 3. The 9 is 1, 2, 3, 4, 5 spots over from the 6. But the 12 is 1. Wait, how did you get that to work? Okay.
I genuinely don't know either, but I did.
Hold on. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. Okay, I take it back. It looks perfect. So really good job, Sam. That x-axis scale is actually perfect. I thought you were off on there, but I was wrong. So good job. Okay, so now let's take a look at his answer. At around 125 centimeters, the growth in distance is random. So there isn't really a way to solve this with much precision. However, based on the range of growth, 125 centimeters at 8 seconds is a great assumption. Now, I like that you wrote a full sentence. That's perfect. I also like that you drew that little red dot on there and you made it a different color than your other dots. And so that let me know that that's where you're estimating, that's where you're estimating, what's the word I'm looking for here? That's where you're doing your estimation for how far the car would travel in 8 seconds. So that's a really good way to do it. If you look, it's so 6, and then the one thing about your scale is these numbers in between are all decimals, so that's probably why you didn't put them down. So 8 is like kind of like right here, like right in between 6 and 9. At least I think so. If it's 3 and then you like, okay, so maybe it would actually be a little bit more over this way. But I don't worry about that. That's not the point. Is you picked a spot in between 6 and 9, approximately where 8 would be, and then you went up to the graph, and then you followed it over to the y-axis. I think if I would have done it, I think I might have picked somewhere more like right here for where the red dot should be. But in general, everything that you did is fine here. This is really good. Like I said, if you want an exact answer, you're going to need to use the equation for the line. And we're going to cover that eventually, but I'm not ready to teach that yet. Okay, so really good job, folks. Let's leave it at that for the graphing practice. Hopefully you all were able to make corrections based off that. And so I appreciate that. Okay, let's continue on with the lesson then. The next thing we're going to do is take notes on slope. So go ahead and get your notebook out. And what I'm going to do is do a little lesson on slope. And you guys are going to take notes on slope and y-intercept in your notebook. And then if you have any questions, just type them in the chat and I'll answer them while we go through the lesson. Does that make sense to everybody?
Yes.
All right, cool. All right, let's do this. Equation of a line. A line, oh, wait, did I miss a? I feel like I'm missing a slide. You can title this in your notes, slope, and this is still unit 1, and the date is 9/17. That's the slide that I'm missing. Okay, so equation of a line. It's always going to be in the form y equals mx plus b. Hopefully you learned that in math class. If you haven't, that's how we write our lines. Y is a dependent variable, so that's what you measure. So if you want to think about the paperclip lab that we did on Monday, what we measured was the mass. We measured the mass using that scale. M is your slope, so that's how much y changes with x, and we'll talk more about that in a minute. X is your dependent variable, so what did you change in the experiment? So if we think about the paperclip lab, I was changing how many paper clips were inside the box. And so for that reason, the dependent variable would be the number of paper clips for that lab. And then B is your y-intercept. The y-intercept will always have the same units as y. So we think about our paperclip lab, y was mass. Mass is measured in grams. So B would have the same units as grams. M, on the other hand, is going to be the units of y over the units of x. And I'll show you what that looks like in just a sec here. Okay. So what is slope? Slope is the rate of change between two variables. How much does y change when you change x? So I'm going to keep going back to the paperclip lab for a reference. If you think about the paperclip lab, the slope of your graph would be how much your y changed. So how much did the mass change when you changed the number of paper clips? So your slope would be how much did the mass change when you changed the number of paper clips? To calculate slope, choose any 2 points on the best fit line. It does not have to be a data point. So I'll talk more about what that means in a minute here, but sometimes when we make our data, the line doesn't go right through all the data points. And so in that case, you don't want to use a data point to calculate the slope. You actually want to pick a point that's on the line. And I'll show you what that means visually in just a second here. Your slope is always your rise over your run. So in formula form, that's y2 minus y1 over x2 minus x1. I like using rise over run instead because I can show that visually and I think students understand it better. But if you're comfortable with the y2 minus y1 over x2 minus x1 formula, you can use that. Okay, let's keep her moving. Okay, so here is a slope example. Trying to find a good place to put the chat so that it's not in my way. Put it over there, and we'll put the participants over here. Okay. So here's a graph. What I want you to do is take a minute, see if you can calculate the slope. Once you think you've got it, go ahead and type it into the chat. Take a minute, see if you can calculate the slope. And then I'm going to show you how to calculate the slope in a minute. So if you have no idea what to do to calculate slope with this one, just hang on and I'm going to show you in just a second. All right. Looks like we got one answer. Anyone else? Anyone else want to venture a guess? Take a shot at it. You got nothing to lose. What do you think the slope of that graph is? There was a tip on the last slide that said, pay attention to scale, don't just look at the boxes. So that might help you out here. Got another guess. So far we've got 2 and 5. Anybody else want to venture a guess? Come on, let's get one more guess. And it's okay if you guess the same as one of the other people too. I mean, there is only one right answer to this, so it's okay if your guess is the same as someone else's, and it's okay if your guess is wrong too, because this really doesn't matter for anything. This is just me sort of trying to get a sense of where we're all at as far as slope goes. Okay, and so then Mohammed, okay, excellent, good. So we got some guess from Najma and Mohammed. So Jay said 5, Jack said 2, Najma said 6, Mohammed said 4, and Alifia said 5. Okay, so let's take a look at this. Sorry, Alfia. So let's take a look at this. So how do we calculate slope? Well, the first thing we need to do is figure out, we're going to take 2 points, and keep in mind that this person forgot to draw the best fit line, but it would just go right through all these data points if they were to have drawn it. So we're going to take these 2 data points, and we're going to estimate what the x values are. So that should be 1 and 3. And then we're going to estimate what the y values are. So that should be 20 and 10. Okay, so to calculate our rise, we're just going to do 20 minus 10, and that equals 10. Right, so I'm just taking this value minus this value. And then to calculate the run, we're just going to do 3 minus 1. 3 minus 1, that's 2. Okay, and so then we're going to use that to calculate the slope. But before we do that, I just want to talk about something. We need to be including units. So this is 20 meters. So that's why we write meters on our x-axis. Oh, Maida also said 5. Okay. We need to be including meters on our x and y axis, or sorry, we need to be including units on our x and y axis, because the units tell us, number 1, what we're looking at, but number 2, our slope also needs units, and when you have your units written, it makes it easy to identify what the units for the slope would be. So this is 20 meters and 10 meters. This is 3 hours and 1 hour. So our run from here to here is 2 hours. Our rise from here to here is 10 meters. Does anybody have any questions on that so far? If you do, feel free to just unmute yourself and say it, or you can type it into the chat. Okay, I'm assuming we're good. So let's go on how to calculate slope. Remember that slope is rise over run. So our rise is 10 meters. Our run is 2 hours. 10 divided by 2 is 5. So those of you who said 5, you are correct. But remember from the earlier slide, we need to include units with our answers in science. So our units should be meters per hour. So meters/hours. Okay, so I'm going to take another break. Does anybody have any questions on anything that we've done for this slide? Anything that's confusing? Anything that you want me to go over again?
How did you, for the run, how did you get 3 minus 1?
How did I get 3 minus 1? So let's go back to here. So when we follow down from this point's at 3. When we follow down from this point's at 1. We always take the point to the right minus the point to the left. It'll be a little bit different for the y. The y is a little bit more confusing about which order it is. But the 3 and the 1 came from this point down here is at 3, and this point right here is at 1. Now, if you were asking, why did I pick 3 and 1, it doesn't matter. I could have done 5 and 2. I could have done 6 and 5 for my 2 points. It doesn't matter which 2 points that you pick as long as they're on the line. And so then I'm subtracting them to get the run because the distance from 1 to 3 is 2. And so that's where that's coming from. 3 minus 1 is 2. And then you just need to include units, so hours. So 3 hours minus 1 hour equals 2 hours. 20 meters minus 10 meters equals 10 meters. Is that making sense? So the numbers just come from, that's what the numbers were below my point, but it doesn't matter which point you pick as long as it's on the line.
Okay, thanks.
Yep. Cool. So hopefully that makes sense to everyone. Does anyone have any more questions? It'd be probably more useful to go over those now because we are going to do a more complicated example in a minute here. So if you're confused on this one, ask so that I can help you, and then that way you're not getting stuck on the more complicated one. So any questions? All right, let's keep her moving. Y-intercept example. So y-intercept is just where the line crosses the y-axis. So remember, the y-axis is the one that goes up and down. Wherever the line crosses, that's your y-intercept. So this one has a y-intercept of 1 because it crosses the axis right here. Okay, let's do a little bit more complicated example. We're going to talk about how to find the slope of this line. Now, the first thing that you should notice is this orange line. It doesn't go through all the data points, right? The data points are like more scattered. Like this data point's a little bit above the line. This one's a little bit below the line. Some of them go through the line, so you could maybe use them to estimate the slope if you want to. But in general, when this happens, what I like to do is just make up my own points on the line. And that's what these gray circles are, this circle and this circle. And I pick spots where my line crosses the grid. So you see how this orange part right here crosses the gray grid? That's going like this. So that's why I picked that point, because I know that it's going to make it really easy for me to estimate this y value. Similarly, for this point, I picked right here because I think this is going to be really easy to estimate this x value because it's right on the line. Okay, so we're going to follow the same steps. Let's figure out where these points are. So this one is here, this one's here. So I estimated this one to be at about 12.5 degrees Celsius. It's in between 12 and 14, but closer to 12. If you don't estimate exactly, don't worry. This is just the approximate slope anyways. If you want to get the actual slope, you'd have to get the equation for this line. And so then 24 degrees Celsius, that's where this point's at. Okay, so then now I'm going to follow it over to the y-axis to get my y values. My y values look like they're at 200. And then this one's in between 500 and 600. I think I estimated it at 580. If you put it at 570 or 575 or something, or 590, it's not wrong. It's just you estimated a little bit different than me. And you'll get a slightly different answer, and that's fine. Okay, so what do we do with those? Well, the first thing we're going to do is we're going to calculate the rise and the run. So our run is this distance right here, right? And we'll use these 2 points to calculate that. Our y is this distance right here. We're going to be using these 2 points to calculate. So for our x distance, we're going to do 24 minus 12.5. Our run is 24 degrees Celsius minus 12.5 degrees Celsius. That works out to be 11.5 degrees Celsius. If you can't do that in your head, use a calculator, right? There's no point in this course where you cannot use a calculator. So if you're not sure, like, how to add something or how to multiply it, don't try doing it in your head. Use a calculator. There's one on your iPad. You can Google one. It's all good. All right, so then for your rise, we're taking this point 580 and this point 200, and we're going to subtract them. So 580 minus 200 equals $380. Notice that I kept using units the whole way through on this. Okay, so now we're going to talk about how to calculate slope. Slope is rise over run. My rise is 380. My run is 11.5. So my slope is going to be $380 over 11.5 degrees Celsius. First thing I'm going to do is divide. So I'm going to take 380 divided by 11.5. That works out to be about 33. And then for the units, I just kept the units the same. Dollars/degrees Celsius. Dollars/degrees Celsius. And that's my slope. Does anybody have any questions on slope? when you do your practice today, this is what you're going to be doing. You're just going to be estimating points on a line, and you're going to try to calculate slope. Note that you can't use this line to find the y-intercept because this isn't 0. This is 10. So really this person didn't do a good job with their graph, because if you think about the scale, it's supposed to go all the way down to 0 over here. But their smallest value is 10. So that's a bad job on their graph. But in general, what you're going to look for, and for the ones that you do on the practice today, is you're just going to look for where the graph crosses the y-axis. So look for where it's going to cross. So for this one, it looks like it's going to cross at 100, but that's not the y-axis because this isn't 0, it's 10. Okay, so that's pretty much all I have for you today. You can go and start working on the practice. It's going to be in the day 4 folder. If you haven't completed graphic practice 1 and 2, you should work on those first. Graphing practice 2 is due today, so try to get those done. Okay, and then if you have any questions, please just stick around in the chat and I will help you. Yep, that's how you should show work, is rise and run is showing your work. Good question, Sophie. Does anybody else have a question? I'm here to support you.
Did I send you a picture of my notes, or like,
What's that?
did I send you a picture of my notes, or do I not have to?
You don't have to. No, the notes are for you. But if you want me to take a look at your notes, I will. I mean, don't feel like you can't send me your notes. But you don't have to. No.
Okay.
Yeah. The notes aren't graded or anything. The notes are just something that you should do to help you, do better on the formative assignments and to, prepare for the summative. Because then once it comes time to study for the test, you have your notes for the test.
Okay, thanks.
Yep, no problem. Oh, bye, Maida. Good job today. If you have any questions, hop back in the chat and I'll help you. Let's see here. Is anyone here? I'm going to stop sharing. Is anyone that's still in? Did I mark them absent? Don't. Oh, yep. Althea, I marked you absent before, so you're present now. So you might get a message from the district, but don't worry, you are present.
Okay. I have a question.
Uh-huh.
About the practice too. So graph like in like